Should I repeat? No, I shouldn't now, okay? Anyway, like that, can I use 1, 2, 3 to estimate? I have a mean, population mean, which is mean, mu, population variance is sigma square. These two are the ones that I'm most interested in finding because these are the population data. I'm very interested, but I only take 3 data. Can I make use of this 1, 2, 3 to estimate mu? It's not mu. I take average. I won't get mu. Can I use this? Use the okay, whatever. Use 1, 2, 3 to estimate mu. Actually can. Actually, short of any other way I can use sample mean. It's 1 plus 2 plus 3 divided by 3, I get 2. Notice I use the word sample because I only take 3 data points. 1, 2, 3. Sample mean is 2. I'm not saying mu is equal to 2, but 2 is an estimate of mu. Follow so far? Not bad lah, okay? Not bad. Of course, it will be better if I poll more people, 450, 400. But not bad. What about the variance? Can we first calculate the sample variance? I'm not sure whether you remember how to calculate. I give you 3 points, 1, 2, and 3. Do you remember? Or cannot remember at all? Cannot remember, right? Okay, then I give you formula. Don't know ring a bell or not. Variance is summation x minus x bar square over n. Which actually means this. Actually, it's not difficult to understand. What we are saying is now we have 1, 2, 3, right? I have 3 data points. Variance essentially is measuring the spread of the data. Correct? So what we are saying, now I know x bar is 2. The sample mean is 2. Now we are saying where is the distance, how well spread are all the data points with respect to the mean 2. Because you take x minus x bar squared. That means you take 1. If I perform the actual calculation, it is equals to 1 minus 2 square plus 2 minus 2 square plus 3 minus 2 square over 3 because there are 3 data points. Follow so far? Okay, now then you measure the spread. Then it's 1 plus 1, then it's 2 thirds. Okay lah, teacher also choose the simple values to calculate to make your life easy for himself. So then that is the sample variance. The next question is this. How good is this to estimate? Is it a good estimate for the population variance? We must distinguish very, very clearly. This is the sample variance of 3 data, 1, 2, 3 only. This 2 thirds is this sample variance. What we are interested in is the population variance. Follow. Can you get what I'm trying to say? Later on you'll see that actually, while this is an unbiased estimate, unbiased estimate means if you do enough times, ultimately this will tend towards the mean. Later on you'll see that this is not an unbiased estimate of the population variance. It's not a good estimate. It's not accurate at all. An unbiased estimate, later on you will see that it is not given by this formula. While this is the formula for the sample variance, this will not be an unbiased estimate of the population variance. But what is it? I will show you. So now we go on to the notes. Okay, sorry, this one. Okay, like that. So let's go to the notes. 6.6. Now, what we're saying now is a point estimate. Just now we took 1, 2, 3. The point estimate is, let's say I want to calculate mean. Why like that? There you go. Okay, never mind. Let's say I want to calculate mean. A point estimate, we can use the sample mean, x bar, to estimate the mu, which is summation x over n. Just now, what did we do? Example, just now we did 1 plus 2 plus 3 divided by 3, we get 2, right? This is a point estimate. 2 was the point estimate of my mean. Follow? It can be shown that in order to estimate my population variance, I make use of something called S square. This S square is not the sample variance. It looks like the sample variance, but it is not the sample variance. It is this formula. It is this, looks almost like it, except the denominator is n minus 1, not n. Why is it like that? I don't intend to prove. You can easily search the internet, there's a lot of proof. There's no problem. But it can be shown. Which actually explains why some of you were a bit confused just before CT2 and said, what is this formula in your MF15? I don't know whether you've seen this before. This formula in MF15. This is S square is actually the unbiased estimate for the population field. You realize it is n minus 1, not n. If you change this n to, n, it is actually your sample variance. Follow what I'm saying? Follow. So make a distinction. Okay? Okay? Right. So the rest okay lah. You're okay, go and find out. Okay? So, this one is given in MF15. This is the unbiased estimate of the population units. Okay, I know it's quite heavy. 30 seconds, talk to a friend. Oh, 1 minute, 1 minute. Some of you asked for the proof. I don't intend to prove it. You can click. Actually, I can click. You cannot click. Or you just type. Anyway, you can Google. Not a problem. Okay? Can? So, the most important thing is we must know that this is the population. You have a mean, you have a sigma. These are population parameters. We must make a distinction between the sample mean and sample variance. Because when you calculate, you are calculating sample mean, sample variance. You are using it to estimate mu and sigma squared. Okay? Sample mean is a good estimate, it's an unbiased estimate. I mean, you do enough times the long-term average value, you will get mu. Sample variance is not good to estimate the variance. You must use something called S squared unbiased estimate. But the thing is, the S squared formula is very similar to the sample variance formula. So that's where we use. Okay, this is really optional. Actually, we just want to highlight. But you don't know this, you don't lose anything. Actually, it's not difficult to prove. Right or not? It's not that difficult to prove. I can prove it to you right away. Okay? I just want to prove this. Okay? Prove this. S squared is actually 1 over n summation x minus x bar squared. Then what we can do is I multiply n over n. That means I multiply the n here and then 1 over n here, which is the same thing basically. Correct? But now, what is this? This is the sample variance, correct? Therefore, this is equals to n over n minus 1. Okay, last 2 points before we end. In order for the S square to be a very, very good estimate for the population variance, your n usually, if it's large enough, then you will be good estimate. Okay? Quite obvious, I think, for obvious reason. You take more samples, of course, you get a good estimate. Okay? Yeah, that's it. We can continue next Tuesday. Thank you.